We're talking about polynomials. The simplest kind of polynomial is a monomial. And a polynomial is a monomial or a set of monomials that are being added together or subtracted, so they have a sum or a difference between them. Okay? When we're talking about a polynomial, then all polynomials, the degree of the variable must be positive, cannot be decimal, so it must be natural numbers. Okay, everybody knows what a natural number is, right? Starts at 1, actually a whole number, so it starts at 0 and goes on. So the degree of these terms in a polynomial must all have whole number exponents. That means they can't be negative and they can't be fractions. Otherwise, they're not a polynomial. And so you can see these other ones down here. These are not polynomials. We have x is in the exponent, absolute value. Oops. Variable y is in the denominator, square root, m to the 0.75 power. So a polynomial has the exponents are all whole numbers. Okay? The degree of the monomial is the sum of the exponents of its variables. You don't count the exponents for the numbers, just the exponents for the variables when you're looking for the degree of a monomial, okay? Which is what you worked on yesterday. So, okay, so just a real quick one. Letter D here then. Okay. Evan, what's the degree of that one? 5. How'd you get 5? 3 plus 2. Well, there's that b in the middle also, right? It would be 6, right? You have to remember that this one is 1. This is 1 here. So the degree here is 6. Okay. All right. What about letter B here, the constant, 5.6? What's the degree of that one then? Becca? 5.6. What's the degree for that? 0. Good. All right. There's no variable, then the degree is 0 because this could be 5.6x to the power of 0. What's anything raised to the power of 0? It's 1. Okay. Anything to the power of 0 is 1. So this is basically, this says 5.6 times 1, which is just 5.6. All right. Okay, then we talk about the degree of a polynomial. The degree of a polynomial is the degree of the largest term in the polynomial. So when I arrange them from order from largest to smallest, the degree of the polynomial goes with the largest one. So here we have the degree of the polynomial here is 3. That's the largest exponent we have. The leading coefficient then is the number in front of the one with the largest degree, so that would be 5. And then we talked about how many terms there are. So this one has 1, 2, 3, 4 terms. So I would say this is a cubic polynomial because the degree is 3 with 4 terms. Cubic polynomial with 4 terms. But whenever, from now on, when you write polynomials, you should always write them in standard form. So from highest degree to lowest degree. Okay. All right, so let's do some adding and subtracting of polynomials. Now, one thing that's going to happen, and I want you to understand this now is I'm going to mention it now. When we get to chapter 9, I think it is, we're actually going to be doing the same thing we're doing here in chapter 6, but we're going to throw a little different terminology at you. And so when we get there to chapter 9 and it gives us some different information, but really they're going to tell us, hey, add these polynomials. subtract these polynomials, multiply them or divide them. Okay? We'll talk about that more then, but remember now, I'm telling you now, that when we get there, all we're going to be doing is what we're doing here, for the most part. All right, so we add. First thing I like to do when I add polynomials is get them in standard form. Okay? So that I'm working highest to lowest. So here I'm going to make sure these are in standard form. 2x cubed minus x plus 9. Do I need that parenthesis still? No. What's in front of this parenthesis right here? A 1. If I multiply 1 times all of this, what do I get? Okay, that same thing, right? And same here, there's a 1 in front of this parenthesis. So when I multiply everything by 1, I still get those same things. So I'm just going to write them in the correct order. Plus x cubed plus 5x squared plus 7x plus 4. Just want to get them in standard form. Now at this point in time, there are actually two different things you could do. You could add going across horizontally like we have here, or you could line up the like terms and add them vertically. Okay? And so I'm going to do it both ways. Okay? So first I have 2x cubed here, and if I go down here and I look for other x cubes, I have another x cubed there. Okay? So I'm going to put those two together. Positive 2, positive 1 gives me 3x cubed. And we're trying to do this in standard form, so I've done x cubed. Now I want to go to x squared. All right, so this isn't x squared. That's not x squared. Here I have a 5x squared here, and that's it. So all I got to do is just write that one down, 5x squared. Then we go to the first power. So we have negative x, positive 7x. So negative 1 plus 7 is 6. So plus 6x. And then our constants. 9 plus 4 is 13. Okay. So that's one way you can do it. Okay. The other way you could do it then is you could actually write them in their terminology. So if I take the first one and I write it, we have 2x cubed, 0x squared, minus x, and plus 9. So I wrote that one with all the possible terms I could have. Cubed, squared, first power, and the constant. Okay. You notice for the squared I put 0 here. Okay. Is that legal? Okay. Does that have any value? No, it doesn't. Okay, but I can use it there to help me. So then I'm going to put the other ones in there. Okay, I have an x cubed, so I'm going to put that right under my 2x cubed. 5x squared, go under my x squared term. Positive 7x goes under the x term. Positive 4 goes under the 9, the constant. And now I'm just going to add them vertically. And part of the reason I'm showing you this is when we get to multiplication, that you can actually do multiplication this way also, and sometimes it becomes simpler. So here now I have 3x squared cubed plus 5x squared plus 6x plus 13. Now I only show you that because some of you are going to like this better than this. How many of you might be that be the case? Shut down. Okay, all right. Sam says she likes it. Okay. So, but the thing is, you might get there when you've got a lot of them, a lot of terms. Sometimes it can get confusing trying to match them up when they're all written horizontally. But if you line up the like terms vertically, then sometimes it makes it a little bit easier. All right, let's look at another one. This one has subtraction, though. So we'll start with the first parenthesis. Okay, what's the number in front of the first parenthesis? Positive 1, right? So when I distribute positive 1, is it going to change anything? No. Okay, so we drop the signs and just write it in standard form. Negative 2x squared plus 3. So then what does this minus sign mean in front of this parenthesis? Okay, it means it's negative 1 there, right? So I'm going to distribute negative 1, which does what? Switches all the signs. And sometimes people have a problem remembering to do that. But just remember, what we're doing is we're multiplying everything by negative 1. Negative 1 times x squared, negative x squared. And I'm going to keep doing it in standard form. So negative 1 times negative x, it's a positive x. Negative 1 times 6, negative 6. Okay? So basically what we're doing is we're dropping the parenthesis and changing the sign. Then we can combine the like terms. X squareds, I got them here. So that'll give me negative 3x squared. I have just one x term, so plus x. And then 3 minus 6 is negative 3. And that's your answer. Like that? Nailed it right on, didn't I? Okay. All right, questions? Now, there's one thing that I want to remind you of before we go any farther here, is that when we get to multiplication, and I throw one of these at you when we've been multiplying, some of you will multiply here. Okay? Always remember, if there's a plus sign or a minus sign between the parentheses, you add or subtract, you do not multiply. All right. So I want you to do these two. Make them nice and big so our friends in the back can see. Okay, polynomial functions is a function whose rule is a polynomial. In this course, you'll study only polynomial functions with one variable. We're not going to throw two variables at you in this. Okay, so here's a business application. The cost of manufacturing a certain product can be approximated by f of x equals 3x cubed minus 18x plus 45, where x is the number of units of the product in hundreds. It says evaluate f of 0 and f of 200 and describe what the values represent. So we're using this function, f of x equals 3x cubed minus 18x plus 45. And it tells us that x is the number of units of the product in hundreds. So first they want us to find f of 0 and f of 20. Well, how do I do that? Leela, what do I do? Fill them in. What do you mean fill them in? Okay. So I'm going to put 0 in for x. Okay. So first we'll put 0 in for x. So we get f of 0 is equal to 3 times 0 cubed minus 18 times 0 plus 45. I love putting zeros in for variables. Why is that so much fun? It's easy because they all end up being 0. Okay, so this is simplifies to 45. Then we'll do it with 200. Okay, so when you add them up, when you put in 200, you should get 24,003,645, right? Oh, I didn't add it. I added it instead of subtracted it. Oh, darn. All right, so what'd you get? What? Okay. 355. Okay. All right. Well, if it was a plus sign there, it would have been right. But 445.
Ah, you messed up, Sam.
Now we really got issues, don't we? 445, not 355. Okay. So there's our numbers. What do they represent? Okay. So first one is the number is 0, right? 0 what?
Teddy bears.
Okay. Okay, where X is the number of units of the product in hundreds. So if there are 0 hundreds, then there are 0 products. Okay. So if they produce 0 products, it's going to cost them $45. Okay. And if we produce, what's the 200 represent? Let's see. It's 200 hundreds, right? So that means we're going to have 200 for my 200, and then I'm going to need 2 more zeros. So 20,000, because I'm going to end up with 4 zeros here. If we produce 20,000 products, its cost is $23,996,445. Costs a lot more then, doesn't it?
Yeah, but you make them.
Right. Hopefully you're making more then. Okay. All right. All right, so do this one for me. Okay, everybody got a graphing calculator in front of them? Okay. All right, all we're going to do is we're going to look at graphing polynomials on your calculator and describing what happens and identifying how many real zeros there are. Okay. So how do I know if it's a real zero or not? If something is a real zero? If it crosses or touches the x-axis, it's going to be a real zero. Okay. All right, so we go to our y equals. Oops. All right, for letter A. Now make sure none of these plots are on. Okay. All right, type it right in. 2x cubed. Turn them off. You go up to there and hit enter. And it'll turn them off. Okay, so if I went and have that plot on, I can just go back up to it, hit enter, and it's off. If they're on, they'll graph scatter plots. Okay.
Like this.
You're all good. Yep, you're fine. Oh, wait a minute. What happened?
Yeah.
Yep, you gotta. Okay, now, follow me. So some of you need practice with the calculators. So I got 2x cubed. All right, now you can put the cubed in there two ways. You can use the caret key and put the 3 up there, or if you go math number 3, it'll put the 3 up there for you. Okay? Okay? The first one, we're doing this letter A over here. So to do 2x cubed, I'm going to go 2x, and then I'm going to go math and number 3 to get my cubed. All right? You can use the caret here. The problem is if you use the caret, it stays up there. And then you have to scroll over for it to come back down. So minus 3x. Right. Now some of you, see this is the problem if I use the caret here, make it 2x to the third power, and then I hit minus 3x. Well, that minus 3x doesn't belong in the power, does it? No. Okay. So if you're going to use the caret, you have to push the right arrow key so it goes back down to the same side, and then you can put minus 3x in. Okay? All right. All right. So then hit zoom, what? 6. We want our standard viewing window, so hit zoom 6. And then you should see this graph. So I'm going to describe this graph as it goes from left to right. So Emily, what do you see happening to the graph as it goes from left to right? What's it doing? Okay. What happens is as it goes left to right, it's doing what? You don't have to get real technical, okay? Just tell me what you see. It does what? Okay, goes up and over. Does it ever go down? Yes. So it goes up, comes back down, and then it goes up again. Okay? If you want to get more technical, you could say it's increasing, and then decreasing, and then increasing again. Okay? Any of those two terminology is fine with me when you describe this. From left to right, it goes up, comes back down, and then goes back up again. There you go. That's all the description you need. Okay? And then how many times does it cross the x-axis? 3 times. So we would say that there are 3 real zeros. Okay? So this graph, actually I think I got it right there. Okay, looks like that when you close in a little bit. From left to right, the graph increases, then decreases, then increases again. Crosses the x-axis 3 times, so there are 3 real zeros. Okay? So you can say up or down, you can say increasing, decreasing if you want, whichever works for you is fine for me. Okay, and then do it for letter B. So clear that one right on out of there. All right, Haley, what does this one do? It does what? That it? Does it come down and go back up again? Okay. Then it comes back up again, right? So it looks like that. Okay. How many real zeros does it have? 4. So then the graph goes through here somewhere, right? Okay. So that's how I describe it. It goes down, decreases, then increases, and decreases again, and finally it increases as it goes from left to right, and it has 4 real zeros. Okay. Questions?